breathe in softly, and let the noise of the day drift away. Tonight, we journey through the quiet wonders of the cosmos, through worlds of fire and diamond oceans of glass and air, and the silent rhythm that binds them all. Out there, among the turning planets and sleeping stars, the universe breathes in patterns both infinite and familiar. It hums with the same pulse that moves through your own chest, steady, ancient, alive. As we drift through these celestial stories, let your thoughts slow to the pace of orbits, your breath match the calm expansion of space. This is not just a story of planets and light. It is a story of connection, of stillness within motion of time unfolding like a quiet tide. So settle in and let the universe unfold one luminous whisper at a time. Let your breathing slow. Allow your body to soften into this moment. We begin by leaving behind the pulse of our daily world, stepping gently into the quiet vastness where planets spin their silent dances around distant stars. In this stillness, we turn outward beyond the blue dot of Earth to reflect on the immensity of the cosmos and the multitude of worlds that lie unseen. Night after night, when you lift your eyes to the sky, you see the bright pinpoints of stars. But what you are seeing is only part of the story. Each of those stars may be orbited by planets, and recent work by astronomers shows that in our own galaxy, the NASA reminds us that there are more planets than stars. Each planet is its own world, shaped by the dust gas and gravity of its birth nebula, each moving in a rhythm unique to its star. Think of them as silent companions to starlight, drifting through space, without fanfare, yet full of quiet possibility. The Milky Way itself holds hundreds of billions of stars, and likely hundreds of billions of planets. Among them, some may resemble our home in size or composition, while others will be wildly foreign worlds of roiling heat, diamond cores, twin sun skies, or no sun at all. For now, we don't know what they feel like up close, but we do know that their existence expands the canvas of the universe and invites our wonder. As we drift further from Earth's familiar light, imagine leaving behind the gentle blue glow of our atmosphere. Imagine hovering in space, where the stars stretch out like scattered lanterns across the black velvet. The hum of the city falls away, the rustle of wind hushes, and you are suspended in a sea of quiet. This is the stage on which our story will unfold, a journey across worlds, each revealed in its whisper of light. We begin with curiosity. Why are there so many planets? What shapes them? And how do they differ? Listen to how the telescopes of the last 2 decades, drifts of light and shadow themselves, have transformed our knowledge. The Kepler Space Telescope and its successor, the Transiting Exoplanet Survey satellite tests, hunted the tiny dimmings and wobbles of stars to find these distant companions. Each time a star flickers, it may indicate a planet passing across its face, a new world, quietly announced. And so we drift. No hurry, no urgency, simply motion in the dark. Our human notion of when day ends and night begins fades. Our pulse slows. In this space between worlds, we stretch our imagination and let it rest. In one sense, this chapter exists to open the door, to invite you into the journey and set the tone of calm exploration. We push aside the notion that we are alone or Earth-centric. We turn our attention outward while remaining anchored within ourselves. From this vantage point, we pause, we breathe, we wonder, and we begin to see what might have once seemed impossible. As the hum of the stars lengthens into silence, our mind opens to the possibility of immense variety, that a planet might orbit a tiny red star, or drift through the depths of space without a parent sun. that each world in its orbit or solitude has been forged by the same cosmic forces that gave birth to Earth: gravity, time, light, dust. Now slowly, we leave the quiet edge of known space and prepare to dive into worlds of remarkable extremes, where the heat burns brighter than many stars, where atmospheres escape into space, where light becomes both familiar and strange. And if you'll allow it, we will drift there together. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. The journey carries us now from the quiet outskirts of cosmic possibility into a realm of fierce brilliance. Imagine a giant planet, far more massive than Jupiter, swirling perilously close to its star. A world where day never ends, where light smothers shadow, and where the very air bends into flame. This is Kelt 9b, an ultra-hot giant surviving in an environment more fitting for a star than a planet. It orbits its host star every 1.5 Earth days, a complete year in 36 hours. At a separation of only about 3 million miles, 10 times closer than Mercury orbits, our sun Kelt 9b is drenched in blistering stellar radiation. Its dayside temperature climbs beyond 7,800 degrees Fahrenheit, or roughly 4,600 Kelvin, hotter than several stars we observe in the night sky. As you envision that planet, feel the tension of its existence locked in a perpetual day, its star-facing side lit like molten metal, its night side never fully cooled, because even the dark endures heat from relentless irradiation. Researchers have discovered that on the blazing daytime hemisphere, molecules such as hydrogen become torn apart, dissociated into atoms by the intense energy. Some of those atoms drift to the cooler night side, recombine into molecules, then cycle back into daylight, only to be ripped apart again in a continuous flux. Picture atmospheric winds, hundreds of miles long, driven not only by heat, but by materials that shouldn't be airborne, metals and ions, once bound in molecules dancing free in this planet's upper skies. Iron, titanium, calcium atoms, normally locked deep below planetary surfaces here, rise, shimmer and escape into the void. Yet in the face of such ferocity there is a strange elegance. The planet's atmosphere is ballooned by the radiation. It puffs outward like a flame-lit jelly, nearing the boundary where gravity's hold loosens and gas can stream away into space. The planet may even be shedding tens of thousands of tons of hydrogen every second, a whisper of loss across cosmic time. In this moment we feel awe, not fear, because we observe from afar. We are not consumed by these flames. Instead, we witness a world where extremes are normal, where matter is forced to bend under irradiance and gravity into new forms. We breathe slowly, our minds stretching to contain the scale of such heat, such closeness to a star, such endurance. And yet, the very existence of Kelt 9b expands our imagination. It teaches us that planets are not merely benign blue spheres or lifeless rocks, but can be incandescent, turbulent, volatile. The line between planet and star dissolves under the heat. If daytime can reach photospheric temperatures, then what do we call this companion? The distinction fades. Indeed, this world is a testament to nature's willingness to break its own categories. As we drift in thought through that searing daylight, consider the rhythm of heat and flow, how energy arrives, how matter responds, how planetary identity is shaped not by habitability, but by endurance. In cosmic time, Kelt 9b may live only a few tens or hundreds of millions of years before its star swells, engulfs it, or the gas drifts away completely. Yet in its brief blaze, it shines a lesson that planetary diversity includes fire, not just calm. And now, with the image of that incandescent giant warming our sense of what is possible, we prepare to turn inward to worlds where the heat is replaced by pressure where fire yields to crystalline weight. From extreme light and flame, we move to interior darkness and hidden gleam. And so we glide from the sun-forged inferno of Celt 9b toward the next quiet wonder, allowing our breath to slow, our heartbeat to settle, and our minds to open to what lies in the deep hushed places of the universe. Out here, far from the blinding heat of the last world, the light begins to fade into something softer. The glare of Celt 9b's eternal day dissolves behind us, and once again the stars surround us in silence. Each one seems to breathe faintly, like embers floating in the dark. The air, or what we imagine as air, is still weightless, timeless. From this place of calm, we turn toward another kind of brilliance, one that hides within rather than shines outward. It is the quiet radiance of carbon, the element that builds all known life, and yet also shapes worlds beyond imagination. Among the thousands of exoplanets discovered, one stands apart as a paradox of fire and stone. 55 Cancri E, a small blistering world that may hold entire layers of diamond beneath its searing surface. The star it circles is Copernicus, 40 light-years away in the constellation of Cancer. To our eyes from Earth, it appears no different from countless others, but orbiting it is a world so close, so bound to its sun, that it completes a full year in less than 18 hours. Imagine that rhythm as sunrise and sunset compressed into a single Earth day, an orbit so tight that gravity tugs at the planet's very shape. It lies barely 1.5 million miles from its star, 10 times closer than Mercury sits from ours. The heat that bathes it is relentless. Its day side reaches temperatures around 4,000 degrees Fahrenheit, hot enough to melt rock into glowing rivers of lava. From a distance, it might appear like a shard of ember frozen mid-motion, locked between brilliance and destruction. Yet beneath that inferno, something remarkable may exist. When scientists studied the chemical composition of its host star, they found that it contains more carbon than oxygen. On Earth, oxygen dominates. It binds with silicon to make the familiar rocks and minerals of our crust. But if carbon takes precedence, everything changes. In such conditions, graphite could replace granite, carbides could form in place of silicates, and under immense pressure, graphite might compress into diamond. This possibility gave rise to a new class of speculation, the carbon planet, a world whose mantle and crust are built largely of crystalline carbon. If that is true, then 55 Cancri E is not only a furnace, it is a jewel glittering invisibly in the dark, its brilliance hidden beneath layers of molten stone. It is easy to imagine such a world as a cosmic treasure, a literal diamond planet gleaming in space. But the reality is more complex and far more haunting. If we could hover above its surface, we would not see sparkling clarity or crystalline peaks. We would see a planet of deep, black, glossy rock, reflecting faint light from its star like polished obsidian. The atmosphere, if any remains, would shimmer with vapors of carbon monoxide and sodium. Volcanoes might erupt with molten carbon fountains of shimmering magma, frozen almost as quickly as they rise. The horizon would glow red with heat, but the light would never fade to true night. One hemisphere, forever turned toward the star, would blaze ceaselessly, while the other, locked in perpetual darkness, would remain a dim furnace of cooling minerals. Even in its silence, the world would hum with tidal stress as the pull of its sun flexes it rhythmically, kneading it from within and releasing its trapped heat in long glowing scars across the surface. Beneath that crust, pressure mounts beyond comprehension. Hundreds of miles below the surface, the layers of carbon could crystallize into diamond under gravity's unforgiving weight. There would be no light there, no air, no sound. Only atoms arranging themselves in perfect order, each locked to the next each, carrying the memory of ancient stars. Diamonds form from the simplest pattern in nature, each carbon atom bound tightly to four others, forming a lattice of pure strength. On Earth, this structure emerges rarely deep below the crust, born from volcanic conduits and immense geologic patience. On 55 Cancri E, that same process may occur on a global scale. If our own planet holds diamonds as dustings of brilliance, this one may hold them as continents. When scientists modeled the internal composition of such a world, they found that its density and mass could fit the profile of a carbon-rich body. Its gravity would be more than twice that of Earth, strong enough to press every mountain lower, every motion slower. A step there, if such a thing were possible, would feel like wading through invisible stone. And yet, there is a strange comfort in imagining the density not as hostility, but as permanence. While our world shifts and drifts, this one might stand unchanging, each grain of diamond locked in place by pressure and time. The mystery of 55 Cancri E deepened when astronomers observed its light through infrared telescopes. They saw brightness fluctuate over time, sometimes hotter, sometimes cooler, and realized that something dynamic was happening. Its orbit may not be perfectly circular. As it moves closer and farther from its star, tidal forces vary, generating internal heat, much like a heartbeat. That energy could melt portions of the crust into a molten ocean, then allow them to harden again as the planet swings away. What we see flickering in infrared may be a pulse of lava tides, planetary breathing made visible through distant light. For all the headlines that call it a diamond planet, science remains cautious. The data suggest multiple possibilities. It might be rich in carbon, yes, but it could also be covered in a global magma ocean, or shrouded by an atmosphere of vaporized rock. Perhaps the diamond layers exist only deep below, or perhaps the world is something else, entirely something no human model has yet described. That uncertainty is not a flaw, but a gift. It keeps our curiosity alive. In each unknown, the cosmos invites us to imagine. It reminds us that reality exceeds invention. Still, the image lingers, a world of carbon shining invisibly in the void. Its formation tells a story of cosmic chemistry. Long ago, the star that birthed it must have formed in a region of space enriched by dying suns, places where supernovae spilled carbon and heavier elements into surrounding clouds of gas. From that dust came Copernicus and its companion worlds, each shaped by an elemental recipe unique to that patch of galaxy. Our own sun, richer in oxygen, produced silicate worlds like Earth. That star, rich in carbon, made something else entirely. Nature, given a different mix of materials, created a different kind of planet. There is quiet poetry in that adaptability. The universe does not repeat itself. It improvises, endlessly composing variations on a single theme. Imagine for a moment the sound such a planet might make. If we could translate vibration into music, there would be a low resonance, the tone of pressure itself, like the hum of the deep earth magnified 1,000-fold. Waves of seismic energy would roll through crystalline strata, each reverberation clear and deep, echoing for hours. These tremors would not signify destruction, but endurance, the subtle conversation between gravity and matter. Even silence here would have texture. If we could feel it, it would be like standing beside an immense engine of stillness, the air thrumming softly, not with motion, but with weight. This world so far and so different still reflects something deeply familiar. Carbon, the element that gives shape to its bones, is the same one that threads through our cells, our breath, and our thoughts. The same element that glitters unseen beneath that surface, burns in the candle flame on our tables, builds the wood of forests, and forms the base of every living molecule we know. It is as though life and stone share an ancestry, one expressing carbon's flexibility through fragility, the other through permanence. On 55 Cancri E, carbon is unyielding, eternal. On Earth, it dances, breaks, reforms, flows. Both are necessary to the story of the universe. Perhaps that is why the idea of a diamond planet feels strangely intimate. It is not only wonder at a world of jewels, it is recognition. In its extreme, we see ourselves mirrored pressure, shaping beauty, heat, transforming structure, endurance, giving rise to strength. The same laws that govern its blazing surface also rule our atoms. The universe is not distant. It is continuous. As we drift away from 55 Cancri E, its red light fades behind us, dissolving into the darkness of interstellar night. We leave with more questions than answers, but also with a calm acceptance that mystery is the natural state of things. There will always be worlds we cannot see, interiors we cannot touch, truths we can only imagine. And perhaps that is as it should be. The cosmos is not something to be conquered or fully known. It is something to be experienced, to be felt, to be dreamt through. In the vast silence that follows, we float again among the stars. Around us, countless other worlds revolve, each with its own chemistry, its own rhythm, its own story. Some may be frozen, others molten, others cloaked in gas or ringed in dust. All of them, like 55 Cancri E, are part of a greater pattern, a cosmic mosaic built from variations of temperature, gravity, and time. We have touched only one fragment tonight, one glimmer in an endless array. Soon we will turn our gaze toward even stranger skies, places where a planet circles not one sun, but two. Their light itself splits and multiplies, casting overlapping shadows that move in slow, delicate balance. The journey continues, carrying us from the inward gleam of carbon to the luminous symmetry of twin stars. But before we drift on, take one last breath here, in the darkness. Let the image of that carbon world settle into your mind, a sphere glowing faintly from within its heart, made of the same element that fuels our own breath, its strength forged from the same physics that built our bones. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. Beyond the diamond world, we drift once again into the open dark, where distance folds and light softens to a dim ocean of silver haze. The silence here feels deeper than before, as though space itself holds its breath. Ahead, a pale shimmer breaks the monotony, a binary star system, two suns locked together in gravitational harmony, turning endlessly around a shared center of mass. Their light spills across a world that circles them both, bathing its surface in a rhythm no single star could ever compose. This is not a fantasy painted by storytellers of faraway galaxies. It is real, and it is magnificent. The planet we approach is called Kepler 16b, discovered by NASA's Kepler Space Telescope in 2011. It lies about 200 light-years away within the quiet star field of the constellation Cygnus. It is a world roughly the size of Saturn, made of gas and ice, orbiting two small suns that rise and set together in the same sky. This is what astronomers call a circumbinary planet, and until the last decade, it existed only in the imagination of science fiction. Yet here, it is serene, balanced, and proof that nature is far more inventive than our stories. Picture it now, two suns, one orange, and one faint red, rising from the same horizon. As the larger star brightens the smaller trails behind, and their twin light spreads across vast swirling clouds, the color of daylight shifts subtly from peach to amber. A living gradient, painted across an atmosphere, thick with reflected brilliance. On the surface, if one could stand there, the shadows are doubled. Two silhouettes fall at different angles, stretching and crossing, blending into a choreography of light and motion. Every sunrise would be unique, every sunset a duet of glowing arcs fading into violet haze. The idea of such balance seems improbable. Two stars pull on one another, tugging with immense gravitational force, while the planet circles them both. Yet mathematics reveals a pattern of stability, a region of calm where the planet's orbit can remain unbroken. Each cycle is a slow, elegant dance star to star planet, to both light to shadow. From afar, their motion looks effortless, but hidden within is constant tension, gravity, balancing gravity chaos, resolved through motion. The universe thrives on such contradictions. The very thing that could destroy the system, those opposing pulls, is what gives it equilibrium. A binary star system is a conversation in physics, two suns exchanging energy, light and rhythm through perfect compromise. It reminds us that harmony is not the absence of force, but its balance. Perhaps that is true beyond the stars as well, that stability in life comes not from stillness, but from motion that sustains itself from dualities finding rhythm. Kepler 1.6b orbits its suns once every 229 Earth days, roughly the length of an autumn turning to spring. To us, it is a frozen gas giant, its temperatures hovering around -100 degrees Fahrenheit. Yet to our imagination, it becomes something more, a symbol of cooperation between extremes. Two sources of heat, two sources of gravity, merging into one continuous system of survival. Astronomers have since found many more circumbinary planets, some smaller, some larger, each revealing new possibilities for habitability. The Kepler and TESS missions have shown that binary systems are not rare. Nearly half of all stars in our galaxy exist in pairs or multiples. For decades, scientists assumed such environments would be too unstable for planets, the gravitational dance too violent to allow the delicate balance needed for formation. But the universe once again proved our caution wrong. Dust and gas found their way to equilibrium. Planets condensed where theory said they could not. Creation, it seems, finds a way even in the most complex rhythms. If you listen closely, if you let the silence between your thoughts expand, you might almost hear that rhythm. The steady tug of binary stars is like a cosmic heartbeat. Gravity is their pulse, light their breath. From our perspective, their movement unfolds over centuries, yet the laws that govern them operate in perfect precision every second. Time, distance, and force woven into one eternal waltz. Imagine the sky of Kepler 1.6b as its twin suns descend. The larger star slips below the horizon, first painting the clouds in amber fire. The smaller remains casting long crimson shadows that seem to stretch forever across the gaseous plains. For a few moments, the two disks overlap, a brief eclipse, before both vanish, leaving the planet bathed in soft twilight. Night comes, not as sudden darkness, but as a slow exhale, a fading glow that lingers in the upper atmosphere, scattering colors long after the light itself is gone. This world, though lifeless, feels alive. Its skies pulse with changing light, its weather patterns shift under the combined heat of two stars, and its orbits echo a story written in motion. To study such a place is to glimpse the mechanics of creation, how gravity sculpts possibility. Binary stars are reminders that nature does not seek simplicity. It revels in complexity and yet produces order from it. Their mutual orbit ensures stability, and the planet's own path finds safety in that constant motion. In many ways, our own lives mirror this principle. We too orbit between dualities, work and rest, chaos and calm, uncertainty and peace. Like a planet, circling two suns, we find balance, not by standing still, but by keeping rhythm with opposing forces. Perhaps that is why this image, a world beneath twin dawns, feels so profoundly human. It is a portrait of coexistence, of balance through movement. From a scientific view, circumbinary systems also expand the field of habitability. Two stars mean complex climates, wider habitable zones, overlapping temperatures, or periodic cycles of warmth and cold. While Kepler 16b itself is gaseous and cold, other systems might host rocky planets where dual sunlight nurtures stability rather than chaos. Astronomers search those skies, carefully looking for faint transits that reveal such worlds. Each discovery not only redefines what is possible, but reshapes our imagination of home. It is strange, isn't it, how the language of astrophysics so often drifts into poetry? When we speak of orbits, we speak of relationships, bodies bound by invisible lines of gravity, neither fully free nor fully trapped. Each depends on the other's motion to remain whole. The same physics that binds a planet to its star binds galaxies together, atoms to atoms' hearts, to their own fragile rhythms. The scale changes, but the principle endures. Motion creates connection. If we could hover near Kepler 16b and watch from afar, we would see both suns reflecting off its atmosphere, one brighter, one dimmer, casting two luminous bands across its hazy curves. The planet itself would look like a mirror, its upper clouds glowing in gold and rose. Beyond it, the two stars orbit one another in graceful slowness, a cosmic yin and yang. The space around them hums with energy, yet the silence remains complete. No sound travels here, only light and gravity communicating through the endless vacuum. There is something deeply soothing in that idea, that even without sound, the universe carries music. It is written in the regularity of orbits, in the recurrence of eclipses, in the way light fades and returns. Every system, from the smallest atom to the largest cluster of galaxies, participates in this rhythm. We, listening from our quiet blue world, are part of that same song. Eventually, we must leave this place too. Our imagination drifts outward, once more carried by the same invisible forces that hold Kepler 16b in place. As we depart, the twin suns sink behind us, their light merging into one warm glow before dimming completely. The planet continues, its orbit unwavering, unhurried. The balance endures, whether we watch or not. And so we carry its lesson with us, that duality is not opposition, but complement, that light and shadow need each other to exist. From this harmony of two suns, we move toward new kinds of weather worlds, where motion becomes storm and light transforms into shards of glass dancing on the wind. Ahead lies another revelation, the art of chaos turned beautiful. Let your breath slow again. Let the image of two suns fading into a single horizon rest in your mind. For just as gravity unites them, the memory of their light will linger within you, gentle and steady, a reminder that even in the most complex systems there can be peace. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. The light of the twin suns fades behind us as we continue our slow drift through the galaxy. The space ahead darkens, once again cool and expansive, the hush of infinity returning like a calm breath between waves. The stars are steady companions, now their glow as constant as the pulse of a heart asleep. As we move deeper, the air of imagination grows heavier, with clouds not the white cotton veils that drift above our skies, but storms that defy our earthly comprehension. we are entering a region of alien weather, where rain is made of molten glass, where winds scream faster than sound, and where the familiar rules of climate unravel into cosmic artistry. To understand such weather, we first recall the way it begins at home. On Earth, sunlight warms the ocean and drives the gentle dance of air and water evaporation, condensation, rain. Pressure systems swirl, temperature gradients rise and fall, and storms are born. It is delicate, complex, but comprehensible. Yet far from Earth, under alien stars, weather behaves in ways that seem almost magical. The same physics apply, but magnified gravity, heavier heat, fiercer atmospheres, thicker or thinner than our imaginations can easily hold. Consider one of the most studied exoplanets, known for its violent skies. HD 189733b. A gas giant, some 63 light-years away, in the constellation Vulpecula. Its color, a deep sapphire blue, once deceived observers into imagining tranquil seas or calm skies. But that blue is not ocean. It is scattered light from silicate particles suspended in its atmosphere. This planet, slightly larger than Jupiter, is a hot Jupiter orbiting so close to its star that a year there lasts only 2 Earth days. It is tidally locked, showing one face eternally to its sun, while the other remains in perpetual darkness. Between these extremes, the atmosphere rages with storms unlike any seen in our solar system. Temperatures on the dayside reach nearly 2,000 degrees Fahrenheit, hot enough to vaporize iron. Winds rush from day to night at speeds of 5,000 miles per hour, carrying clouds of molten glass across the sky. Imagine that for a moment, a horizon filled with glittering shards, swept sideways by unimaginable gales, the glass never falling, only whirling endlessly in the high atmosphere. If light could have texture, this is what it might feel like: sharp, dazzling, chaotic, and eerily beautiful. Through telescopes like the Hubble and Spitzer space telescopes, scientists have detected these violent motions by watching the way the planet's light changes as it moves around its star. By studying spectra, we can infer the chemical fingerprints of its clouds, the fingerprints of silicate and metal vapor. Each observation gives us a piece of the weather story, written not in raindrops or thunder, but in wavelengths and reflection. And yet, even amid such fury, there is a strange serenity. The winds do not rage out of defiance, but out of balance. Energy must flow from hot to cold, from day to night. The motion of those storms is not chaos, but equilibrium in disguise. Nature's principle of conservation plays out here in a ballet of heat exchange, written across a canvas 50,000 miles wide. What seems violent from our perspective is to the universe harmony, the equalizing breath of a living atmosphere. Other planets, too, host storms that astonish. On Jupiter, our own gas giant, the Great Red Spot, has raged for at least 3 centuries. A single storm large enough to swallow Earth whole. On Neptune, winds blow at over 1,000 miles per hour. Despite its great distance from the Sunday energy, it seems finds a way to dance, even where light grows faint. And beyond our solar system, this truth multiplies. There are exoplanets, where iron condenses in the upper air, raining droplets of metal that vaporize before they ever touch the ground. Worlds where methane forms clouds of ghostly white and lightning, flashes not blue or white, but violet, tearing through hydrogen skies. Some planets possess atmospheres so dense that heat cannot escape, creating perpetual tempests that never calm. Others, stripped nearly bare, still manage to host winds that roar over rocky plains of frozen carbon dioxide. Each of these worlds reminds us that weather is universal. The art of energy seeking balance, but its expression depends on the materials at hand. On Earth, water sculpts rivers and snow. On HD 18973, 3B glass and iron take their place. It is the same equation rendered in a different palette. The tools that let us glimpse these alien climates are themselves marvels of quiet precision. The James Webb Space Telescope, launched into its perfect orbit far from Earth's interference, has already begun to read the atmospheres of distant planets through infrared light. It can detect the glow of heat from a world hundreds of light years away and tell us whether clouds, gases, or storms fill its skies. From those faint traces, we reconstruct entire weather systems, a kind of planetary meteorology practiced across the vastness of space. And as those signals return, they reveal not only the violence of alien weather, but its rhythm. Scientists have found temperature differences from one side of a planet to another, so great that entire jet streams must carry material around the globe in mere hours. On some planets, clouds form and evaporate within minutes. On others, storms may last for centuries. These worlds breathe heat and wind like lungs of gas, and light exchanging energy with their stars in constant conversation. Pause for a moment and picture one of these places. A sky of glowing blue glass winds curling in vast gyres, clouds shimmering like molten mirrors. There is no up or down, no ground, to stand on only layers of atmosphere, each one more immense than the last. Light filters through dust and vapor, scattering in ways that paint color across the spectrum gold. At the horizon, deep indigo overhead. The horizon ripples with heat, and yet within that turbulence there is symmetry, a hidden calm in the ceaseless exchange. When astronomers model these storms, they find echoes of familiar patterns: jet streams, vortices, polar bands. Even in the most alien places, the geometry of weather repeats itself. The laws of fluid dynamics know no boundaries. They do not belong to Earth alone. They write their signature everywhere matter flows. And so in every planetary tempest, we recognize something of home, a reminder that the same equations that shape our breezes shape the winds between stars. There is a deeper metaphor here too, if one chooses to see it. Weather is transience, made visible the atmosphere in motion, energy in transformation. It teaches us that even extremes are temporary, that no storm lasts forever, no matter how large or luminous. The same principle that moves clouds across an alien sky moves emotions through our heart's pressure, seeking balance, heat dispersing into calm. Nature's equilibrium is both physical and spiritual. Imagine drifting above one of those hot Jupiters, far enough to see its entire surface at once. From that height, the storms no longer appear violent. They form patterns, whirls of light and shadow, each moving predictably around the planet's axis. The winds that once seemed like chaos now appear as gentle rotation, vast, ordered, hypnotic. From this distance, even turbulence becomes serene. The universe invites us to widen our perspective until all motion finds its peace. Among all the exoplanets catalogued so far, thousands show evidence of atmospheres, and dozens hint at weather systems. Some are young, their clouds still forming. Others are ancient, their gases thinned by time. Each world is a laboratory of climate, a reminder that balance takes many shapes. Where one planet rains, iron another condenses methane snow. Where one burns with radiation, another freezes under a pale sun. The variety itself is harmony, a chorus of climates singing the same universal song. It is humbling to think that even here, in the vacuum between stars, something so ephemeral as weather persists. It is not bound to air or ocean. It exists wherever energy flows. The cosmos itself breathes through these storms, whispering through heat and motion, reminding us that movement is life. Stillness, in truth, is rare an illusion we perceive between the pulses of change. As we drift onward, the storms fade behind us. The blue glass clouds, the molten winds, the metallic rains all dissolve into memory. What remains is understanding that the universe is a vast interplay of temperature and time of equilibrium achieved through endless variation, from the soft clouds of Earth to the razor-sharp rain of HD. 1, 8, 9, 7, 3, 3, B. All weather is the same story told in different dialects of physics. The path ahead leads us toward greater solitude, toward worlds that have no stars at all, wandering endlessly through interstellar night. After witnessing such dynamic skies, we will soon encounter a different kind of beauty: silence, unbroken darkness, complete planets adrift without orbit or dawn. Yet even in that solitude, warmth endures. The journey will remind us that motion and stillness, heat and cold, chaos and quiet are all expressions of one continuous balance. Take a slow breath. Let your mind rest in the calm that follows the storm. Picture the molten rains subsiding, the winds easing into stillness, the planet spinning peacefully beneath the cooling light of its sun. The weather has spoken its language, and now the air is calm once more. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. Drift with me now into darkness, the kind that is deeper than night, older than memory. The stars thin as we move farther from the familiar neighborhoods of light. One by one, the distant suns fade until only faint pinpoints remain scattered like sparks in an endless ocean of black. Here, the cosmos is quieter. There is no dawn, no dusk, only a continuous twilight suspended in time. It is within this boundless void that we find some of the most mysterious travelers in the universe. The rogue planets, worlds without homes drifting endlessly through interstellar space, bound to no star warmed, only by the faint heat left from their birth. Imagine such a world. There is no sunrise to mark the beginning of its day, no sunset to announce its night. There is only perpetual shadow. Its surface lies beneath a sky devoid of a central sun, illuminated instead by distant starlight, a soft glimmer too faint to cast a shadow. Yet even in this profound solitude, there is movement. The planet spins slowly, carrying a silent atmosphere, perhaps thin, perhaps frozen, perhaps thick, with warmth trapped beneath clouds of hydrogen. Inside, its molten heart still beats, faintly radiating the last of its internal heat into the emptiness around it. Astronomers believe there may be billions of these wanderers in our galaxy, perhaps more than the stars themselves. Some were born in solar systems like ours, and later cast out by the gravitational chaos of their youth. Others may have formed directly from collapsing clouds of gas, never tethered to a star at all. They drift through the galactic void like cosmic refugees, their orbits unbound, their paths curved only by the pull of the galaxy's central mass. They are both ancient and young, still cooling, still moving, carrying with them the silent memory of creation. How do we know they exist if they float in darkness, invisible to telescopes that rely on light? Science has always finds a way to listen, even when sight fails. These planets reveal themselves through a phenomenon called gravitational microlensing, a subtle bending of starlight that occurs when a massive object passes in front of a distant star. For a brief moment, the planet's gravity acts like a lens, magnifying the background light. When the flare fades, astronomers can infer the size, mass, and distance of the unseen traveler that caused it. Through these fleeting signatures, we have discovered worlds as small as Earth and as large as Jupiter wandering alone between the stars. Some may carry frozen oceans beneath thick shells of ice. Others may be giant spheres of hydrogen, still glowing faintly in infrared light. The Wide-Field Infrared Survey Explorer WISE mission and the Nancy Grace Roman Space Telescope, soon to expand this search, help scientists trace their faint thermal glow. They are the hidden population of the galaxy, invisible but vast, drifting through the dark, like forgotten planets of a forgotten sun. If you could stand upon one of them, what would you see? There would be no horizon of sunrise, only the dim starlight of the Milky Way stretched across the sky. The ground beneath your feet might be frozen rock or hard ice, reflecting faint glimmers of faraway constellations. Occasionally a meteor might streak across the heavens, not burning from friction as on Earth, but glowing softly as it enters a rarefied atmosphere. Every sound would be muffled as though the air itself had fallen asleep. In that quiet, even a whisper might seem eternal. And yet, despite their isolation, these planets are not dead. Deep beneath the surface, radioactive decay may continue to generate heat enough to keep a subsurface ocean liquid for billions of years. On Earth, we see a hint of this potential in the icy moons of Jupiter and Saturn, Europa and Enceladus, where geothermal warmth maintains seas hidden beneath miles of ice. A rogue planet, blanketed in an insulating atmosphere of hydrogen, could sustain similar warmth indefinitely. There, in complete darkness, life might exist, primitive, microbial, perhaps never seeing light yet thriving on the slow fire of a planet's core. It is a haunting thought that in the deepest void there might still be oceans, still be motion, still be life. A world adrift, silent and unseen, yet alive in its own secret way. The absence of sunlight does not mean the absence of energy. Even in darkness, chemistry continues. Reactions spark, molecules form and break and reform. Nature is relentless. It refuses to stop creating even when no one is watching. When astronomers simulate the early days of planetary systems, they find that chaos is the rule, not the exception. As young stars ignite, their planets jostle and collide, exchanging angular momentum like dancers in a crowded ballroom. Some worlds are thrown inward and destroyed. Others are flung outward, gaining speed until they escape entirely. Ejection is not failure. It is an expected outcome of cosmic birth. Every solar system, including ours, likely cast away more than one planet during its formation. Those wanderers now drift invisibly among the stars, carrying the geological fingerprints of their origins. Over time, the galaxy gathers them. They become its quiet background, the unseen threads between luminous systems. Each one is a solitary traveler, but together they form a hidden network, a dark architecture beneath the bright map of constellations. When we look up at the night sky, we see only half of what exists: the shining stars, the visible worlds. The rest, the unlit, the unanchored, the forgotten, float in vast numbers, waiting to be found. In the story of creation, rogue planets are reminders of imperfection, of chance, of the gentle chaos that gives rise to beauty. Not every world finds a home. Not every orbit endures. And yet, in their isolation, they embody a form of peace, a stillness born from release. Freed from the tug of any star, they travel, unhurried, timeless, following invisible paths through the galaxy's spiral arms. They have no seasons, no years, no calendars. Time for them is measured only in motion. Imagine gliding alongside one, watching as its surface glows faintly with internal warmth. The planet's horizon is a shadow against the thin light of distant stars. As you drift closer, you see that faint red glow, a gentle heat leaking into the void like breath on glass. You could trace it for hours and see no change, just endless plains of rock and ice sculpted by impacts that occurred eons ago. Occasionally, a small moon itself, captured or orphaned, may accompany it, a faint companion in the dark, orbiting endlessly around its lonely master. There is poetry in their existence. The rogue planet does not rebel against nature. It fulfills it. It reminds us that not everybody needs an anchor. Some things can drift and still endure. Some paths have no center, and that is their beauty. In their loneliness, there is also connection. For even the darkest planet still feels the gravitational pull of the galaxy, still moves within the rhythm of the cosmos. Nothing, not even the most lost world, is truly alone. As the James Webb Space Telescope refines our view of these travelers, scientists speculate that entire families of rogue planets may exist, systems of multiple worlds orbiting one another in darkness, each keeping the other company. Some may retain moons' rings or even faint atmospheres that glow softly in infrared light. In the next decades, as technology improves, we may capture their signatures directly. We will not see bright blue oceans or golden clouds, but faint shadows in the spectrum, proof enough that the universe's creativity extends far beyond the warmth of suns. From a philosophical view, rogue planets are more than scientific curiosities. They are meditations on solitude. They show us that even in apparent isolation, there is motion, purpose, and quiet dignity. In their drifting, they are like thoughts between stars, unanchored, free, carrying potential across unimaginable distances. If the cosmos has a soul, perhaps it dreams through them. As we leave this region of darkness, we carry with us a renewed sense of stillness. The luminous worlds of twin suns seem far behind. The glass storms of hot Jupiters have faded to silence. In their place remains a kind of peace that only emptiness can provide. The rogue planets teach us that silence is not the absence of life, it is its resting state. Energy sleeps, but it never dies. Motion slows, but it never stops. Even now, these orphan worlds continue their slow drift through the infinite, unseen, but real part of the great breathing of the universe. Soon, we will begin to hear again the faint hum of magnetic fields, the whispers of auroras, the music of planets that sing through light. But for now, in this interstellar stillness, let us rest here a moment longer. Let us appreciate the quiet courage of these wanderers, their patience, their grace. They ask nothing, they promise nothing, and yet in their silence, they hold an entire universe of possibility. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. We leave the drifting wanderers behind their lonely paths, fading into the velvet dark. The silence of those unlit worlds lingers, a whisper that echoes across the distance, soft and eternal. But now, as we journey once again toward the regions touched by light, something begins to hum beneath the stillness. It is faint at first, almost imagined, a low, resonant vibration that seems to ripple through the void itself. We are entering a realm where planets do not merely exist in silence, but sing, where invisible harmonies arise from magnetic fields, charged particles, and the breath of stellar wind. This is the hidden music of the cosmos, played not through air or sound, but through light and energy, a symphony beyond hearing, sensed only through the language of physics. Every planet with a magnetic field hums, even our own. Earth's magnetic shield vibrates in response to the charged wind streaming from the sun, creating waves of electromagnetic resonance. When translated into audible frequencies, these vibrations become eerie songs, ethereal, haunting, beautiful. Spacecraft orbiting Earth and the outer planets have captured these sounds: plasma waves, magnetospheric whistlers, chorus emissions, each one a voice of a world. They are not melodies in any human sense, yet they carry rhythm and tone. To listen to them is to hear the deep breathing of creation itself. The largest and loudest of these singers is Jupiter. Its immense magnetic field, 14 times stronger than Earth, stretches millions of miles into space, forming a vast magnetosphere that traps charged particles. As solar wind interacts with this field, radio waves ripple outward, filling space with an invisible choir. When the Voyager spacecraft passed through that field in 1979, its instruments detected the emissions bursts of rising tones and fluttering patterns, like cosmic bird calls echoing in the dark. These are Jupiter's auroral voices, born from the collision of electrons with its upper atmosphere near the poles. Each collision produces ultraviolet light and radio sound light, and tone woven together, physics turn to music. We can imagine standing somehow on one of Jupiter's moons, perhaps Io, that restless volcanic world. Above, the sky would shimmer with auroras far larger than any seen on Earth, rings of green and violet light pulsing at the poles of the giant planet. Invisible waves of energy would sweep past, silent to the ear, but alive in vibration. The airless space around would hum like a distant, endless chord. That hum is not metaphorical. It is the literal oscillation of particles moving in rhythm with magnetic lines of force, nature performing its most ancient composition. Other planets sing too. Saturn produces radio emissions, modulated by its rotation, a steady throbbing tone that scientists call Saturn kilometric radiation. When Cassini's instruments recorded these frequencies, they revealed something unexpected. Saturn's song changes with its seasons. As sunlight warms the northern and southern hemispheres, differently, the magnetosphere's oscillations shift, altering the tempo of the planet's music. It is as if the world itself responds to its star in rhythm, tuning its invisible instruments to the touch of light. Even smaller worlds contribute to this cosmic symphony. The magnetic fields of Uranus and Neptune twist and tilt, oddly causing their emissions to fluctuate unpredictably. And far beyond, exoplanets orbiting distant suns may generate their own magnetospheric melodies, faint signals that our telescopes are only now beginning to detect. The low-frequency array LOFAR in Europe has picked up radio bursts from nearby star systems, likely caused by planetary magnetic fields interacting with stellar winds. They are whispers from light years away, hinting that the song of the universe is continuous and endless, carried across the fabric of space by the language of electromagnetism. In these moments of reflection, we begin to understand something profound. Silence in space is an illusion. There is no true silence anywhere in the cosmos. Where there is motion, there is vibration. Where there is charge, there is resonance. Sound in our limited sense requires air to travel, but the universe sings in frequencies beyond our hearing. Its harmonies are written in plasma and radiation, in the shimmering of auroras and the heartbeat of stars. Each planet contributes its note, low and steady for giants, faint and subtle for smaller worlds, together forming a cosmic orchestra without beginning or end. This notion that the universe hums is not just poetic but measurable. Scientists have recorded what they call space chorus emissions, caused by electrons spiraling along magnetic field lines. When these frequencies are converted into audio, they become hauntingly musical, crackling, whistling, warbling sounds that seem almost alive. The phenomenon known as the dawn chorus, heard by satellites in Earth's orbit, is caused by energetic electrons interacting with our planet's magnetic field at sunrise. It is Earth's daily hymn, a reminder that even our quiet mornings are accompanied by unseen symphonies. Now imagine a civilization far beyond ours, perhaps orbiting another star, listening across light years with their own instruments. What would they hear from our world? They would detect our magnetic heartbeat, our auroras, our lightning storms, our radio chatter. To them, Earth would not be silent. It would be a luminous, pulsing note amid the galactic song, recognizable by its rhythm, unique by its balance of noise and harmony. There is a gentle philosophy hidden within this realization. Every system in the universe radiates not only light, but energy structure information. Even in darkness, a planet's field reaches outward, shaping the space around it. We too radiate thoughts, emotions, intentions, invisible but felt. The cosmos mirrors us in its unseen communication, a vast web of resonance connecting all things. Magnetism, gravity, light, these are the universal languages that bind the stars. When scientists translate radio emissions from planets into sound, what we hear is strangely human. The tones rise and fall like breathing. The patterns repeat with subtle variation, as though expressing mood. It reminds us that the universe is not cold machinery, but dynamic interaction. These magnetic harmonies are the audible footprints of motion energy balancing itself through oscillation. They are proof that the cosmos is not static, but vibrantly alive. As we drift through this unseen concert, picture yourself suspended between worlds. Around you, magnetic lines curve like invisible ribbons, glowing faintly as they capture particles and release them in spirals of light. Far ahead, a pale blue world emits its own hum, while behind a gas giant throbs with deep, slow pulses of radiation. The space between them is not empty. It is filled with the soft hum of fields intersecting, merging, diverging. It is the closest thing to music that the universe can create, and it never ends. There is another layer to this song, one that vibrates even deeper, the cosmic microwave background, the afterglow of the Big Bang itself. Its faint radiation pervades all of space, the remnant of creation's first note. If the universe were an orchestra, that would be its eternal bass, the underlying tone upon which every planetary melody is played. Everything since stars, planets, life thought is a harmony written atop that primordial hum. To understand this is to glimpse unity. The magnetic songs of Jupiter and Saturn, the whispers of exoplanets, the low vibration of the cosmic background, all are connected, all part of the same continuum of vibration. Energy moves, oscillates, expresses itself through fields and waves, and in doing so, becomes the heartbeat of existence. When we listen, even in our limited way, we are hearing not random noise, but the order of creation manifesting through motion. The ancients, gazing at the night sky, spoke of the music of the spheres, the belief that celestial bodies move in harmonic proportion, producing divine resonance. Though they lacked the tools to prove it, they were not wrong in spirit. Modern science has confirmed that the universe indeed moves in frequency, that planets and stars generate measurable vibrations, that reality itself is structured as wave and rhythm. The old metaphor becomes literal. We are surrounded by music, and we are part of it. As our journey continues, the vibrations around us begin to fade again. The auroral glow of Jupiter dims, the pulsing magnetism of Saturn falls away, and the hum of radiation softens into stillness. Yet even as it quiets, we sense it remains continuing just beyond perception. The silence we enter now is not absence, but distance, the song still playing simply unheard. Ahead lies a different kind of harmony, not of motion, but of pattern. The repeating structures that shape all planets, all systems, all galaxies. We will soon see how creation itself follows a rhythm, how dust becomes ring, how chaos becomes order. But before we move on, take one last moment to listen, not with your ears, but with that inner stillness that feels rather than hears. Can you sense it? The universe humming softly to itself, forever in tune. After the hum of planetary music fades, what follows is not silence, but structure. In the long quiet of the cosmos, there is an underlying rhythm, not of sound, but of form. If the universe could be seen as a single composition, then matter itself would be the notes, and the patterns it weaves across billions of years would be the melody. It is this melody we drift into now, the geometry of creation, the quiet repetition that gives shape to all worlds. Every planet, every star, every ring and orbit owes its existence to a simple choreography, a balance between motion and gravity, between collapse and release. When clouds of gas and dust gather in space, drawn together by their own faint attraction, they do not fall inward all at once. They spin. That spin saves them, balancing gravity's hunger with motion's resistance. In time, the cloud flattens into a disk, thin and wide, its particles circling in endless revolution around a newborn star. From this disk, planets are born not randomly, but through patterns that repeat across the galaxy, like recurring verses in an ancient song. If we could watch a solar system form, we would see turbulence resolve into order. Within the swirling disk, grains of dust collide, stick, grow. Static electricity first binds them, then gravity takes over. In millions of years, tiny stones become mountains. Mountains become worlds. It is a process at once violent and delicate collisions that create impacts that seed stability. Out of chaos, symmetry emerges, guided by invisible mathematics. The same principles sculpt our own solar system. The arrangement of its planets, rocky worlds close to the sun, gas giants farther out, is not coincidence. It reflects the physics of condensation. Close to the sun, where heat is fierce, only metals and silicates can survive. Farther away, ices and gases can condense and remain. This gradient of temperature determines everything from the density of worlds to the presence of rings and moons. The same rules apply elsewhere. Every system the James Webb Space Telescope observes shows this same pattern in some form: warmth carving rock distance, creating gas gravity, setting the rhythm for all. There is something soothing about such order. For all its vastness and variety, the universe builds through repetition, a fractal harmony that extends from atoms to galaxies. The spiral of a hurricane mirrors the shape of a spiral arm in a galaxy. The orbits of moons echo the dance of electrons around a nucleus. Everywhere we look, nature speaks the same language of rotation and balance, as though it were composing variations of a single universal theme. On worlds like Saturn, this pattern becomes visible to the naked eye. Its rings, formed from ice and rock, orbit in perfect bands, each one spaced by subtle resonances of gravity. Every ring particle follows its own path, yet together they create a structure of astonishing precision. It is as if the planet's gravity were conducting an orchestra of billions of frozen notes, each keeping time without deviation. Those same resonances appear in distant disks around young stars, where planets carve gaps and waves in the material that birthed them. From the smallest ripple in dust to the grandest spiral in a galaxy, the echo is the same gravity shaping time into form. When scientists model these formations on computers, they find that order arises naturally. No divine hand arranges the particles. The rules themselves are enough. Gravity pulls, motion resists, and equilibrium appears not static, but dynamic, sustained through endless motion. It is the same process that holds our moon in orbit, that keeps the Earth spinning steadily, that ensures the constellations change so slowly we can use them to mark the seasons. Stability, it seems, is born from movement. The universe remains whole, not by being still, but by never ceasing to move. This truth is written not only in space, but in time. Patterns repeat across epochs as well as distances. Stars are born live and die, scattering their material into the next generation of worlds. Every element heavier than hydrogen, the carbon in our cells, the iron in our blood, the calcium in our bones, was forged inside a star that lived long before our Sunday. The cycle of stellar birth and death mirrors the smaller cycles of climate, weather, and life itself. Creation is not a single act, it is a continuous rhythm. Every moment of destruction is also a prelude to renewal. Imagine for a moment drifting above a young solar system. Forming within its nebular cradle, you would see glowing filaments of gas stretching across thousands of miles, rotating in slow grace. In the center, a newborn star flickers with unstable light, its energy pushing against the same matter that feeds it. Around it, concentric rings of dust shimmer in pale gold, faintly illuminated by the central glow. Tiny clumps of matter gather in those rings, leaving behind trails like ripples in water. Each ripple marks a future planet, an idea in the process of becoming real. To watch such a scene is to glimpse the patience of creation. From this vantage, we begin to see the pattern as something almost meditative. Every orbit is a repetition of a thought. Every revolution is a breath. Planets spin not out of chaos, but out of necessity, each turn maintaining the delicate balance between attraction and freedom. Even the chaos of comets and asteroids, those ancient wanderers of debris, fits into this order. Their elliptical paths deliver water to new world seed chemistry, where life may one day take root. Nothing in this system is wasted. Every motion contributes to the whole. The universe at every scale practices the art of recursion, building the complex from the simple repeating motifs until beauty appears. It is no different than the rhythm of waves along a shore or the pulse of a heartbeat in the dark. In both, pattern becomes peace. Perhaps this is why looking at the stars calms us, why the mind finds rest in symmetry, why repetition soothes our thoughts. We are in essence made of pattern ourselves. Our DNA coils in spirals, our cells divide in rhythm. Our breath follows the same cadence as the turning of the earth. We are echoes of cosmic order, experiencing it from within. The realization carries both humility and comfort. Humility because the same laws that shape galaxies shape us. Comfort because it means we belong to something constant. Even as our lives move through change, the grand patterns endure: orbit, rotation, decay, rebirth. Each of us is a brief expression of that infinite rhythm, a momentary wave within the ocean of structure. Astronomers often speak of resonance, the phenomenon where two orbiting bodies fall into a synchronized ratio of motion. Neptune and Pluto, for instance, orbit the Sun in a precise 3:2 resonance for every 3 Neptune years. Pluto completes exactly 2. Their paths never cross. They dance in harmony across millions of miles, bound by mathematics alone. The same principle governs the spacing of Saturn's rings, the gaps in asteroid belts, even the cycles of moons around Jupiter. Wherever resonance occurs, chaos gives way to stability. It is as if the universe naturally seeks music, not sound, but rhythm, not noise, but proportion. And proportion is the language of beauty. From the spiral of a galaxy to the curve of a seashell, the same ratios emerge. The golden spiral, the logarithmic arc, the self-similar unfolding of form. These patterns are not coincidence. They arise from mathematics itself, from the way energy distributes across space. When nature creates beauty, it does so through geometry. When we find beauty in nature, we are recognizing ourselves within it, the shared logic of creation, reflected back in form. Pause here for just a moment and imagine the quiet choreography of all this movement. The planets circling their stars, the stars drifting within galaxies, the galaxies spinning within clusters, and beneath it all the quantum dance of particles vibrating at frequencies far beyond our senses. From vast to small, everything participates in the same timeless pattern motion, seeking equilibrium energy, expressing balance. It is comforting to know that even across unimaginable distances, there is unity. We often speak of space as cold, empty, and indifferent, but look closer, and you see care in its construction, precision, continuity, rhythm. The universe, vast as it is, behaves like a mind in meditation, always moving, yet never frantic, always changing, yet always calm. Soon, our path will lead us from this architecture of matter to its meaning, from pattern to reflection, from observation to wonder. We will ask what all this order tells us about ourselves, about the life that observes it, about the fragile awareness that looks up and sees symmetry in the stars. But before we go there, let us rest in this understanding that the universe is not random, but resonant, that beneath every motion is purpose, beneath every orbit grace. So let the image settle in your mind, a spiral of dust around a young star glowing gently, patient in its creation. Let it remind you that the same spiral lies within you too, in the curve of your heartbeat, in the motion of your thoughts, in the rhythm of your breath. You are made of these patterns. You are part of the same echo. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. In the quiet after pattern we find meaning. We have drifted through burning worlds, diamond hearts, twin suns, glass storms, and lonely travelers. We have listened to planets hum in magnetic resonance and watched dust spiral into the symmetry of creation. Now, in this softer stretch of the journey, we turn our gaze inward to ask what all these worlds reflect back toward us. They are not only objects of study, they are mirrors. Each one in its silence tells a story about endurance, about transformation, about the patience of time. Each one is a chapter in the larger book of existence, written not in words, but in light. When astronomers study distant planets, they do not see them directly. They read the way starlight changes as it passes through an atmosphere, or glances off a surface measuring infinitesimal shifts in brightness and color. From these shifts, they infer composition, temperature, motion, entire worlds, built from shadows and light curves. In that delicate art, there is something profoundly human. We too learn through reflection. We rarely see truth directly. We perceive it through the ways it bends and glows in the presence of something else. Every planet we discover is an echo, a reflection of the universe, learning to see itself. Light is both messenger and memory. It travels across impossible distances, carrying the signatures of atoms and molecules, the whispers of events long past. When that light reaches us, it tells stories that happened before Earth even existed. The light from some of the exoplanets we observe tonight began its journey tens or hundreds of years ago, when telescopes were only dreams. To study that light is to travel backward in time. In its faint shimmer, we glimpse the early chemistry of creation and the unbroken continuity that binds all matter together. Among the most important lessons of this cosmic reflection is that life, or at least the potential for it, seems to emerge wherever conditions allow. The discovery of so many planets in habitable zones, regions where liquid water might exist, reminds us that Earth is not exceptional, but representative. It is one example of what happens when chemistry is given time. Every rocky planet orbiting a gentle star is an experiment in possibility, a trial in the universe's ongoing quest for complexity. The Kepler and TESS missions have shown us that such places are abundant. There may be billions of Earth-like worlds, each with its own climates, oceans, mountains, and maybe even the spark of awareness. The more we look, the less alone we become. Yet even that abundance carries humility. For every planet bathed in gentle sunlight, there are countless more scorched or frozen their surfaces, locked in extremes. And yet, each of them participates in the same cosmic order. There is no failure in their barrenness, no absence of beauty. A world that cannot host life still fulfills its purpose by existing, by balancing gravity and motion, by teaching us how matter organizes itself under pressure and heat. The barren and the blooming are both parts of the same equation, the same art of being. When we gaze through telescopes and capture the faint spectrum of a distant world, we are not just seeing a dot of light. We are witnessing the unfolding of our own curiosity. It is that curiosity, the willingness to look into darkness and ask, what is there, that defines us as a species? In that way, science itself becomes a reflection of planetary motion. Just as orbits are shaped by the tension between gravity and momentum, knowledge grows through the balance between certainty and wonder. We seek stability, but we move through uncertainty. We learn by revolving around the unknown, returning again and again to the same questions with clearer vision. These echoes of light also reveal the fragility of balance. The atmosphere of Venus, once perhaps temperate, grew dense, with carbon dioxide trapping heat, until the planet's surface became hot enough to melt lead. Mars, on the other hand, lost much of its air to space, its rivers and seas, evaporating under a thin sky. Both worlds remind us that stability is rare and precious, that equilibrium between light and heat, pressure and release, is delicate. Earth's habitability is not guaranteed by destiny, but by balance, a balance that can shift. In understanding other planets, we come to appreciate our own in ways that no myth or philosophy could teach. The same light that reveals exoplanets also reveals ourselves. As instruments like the James Webb Space Telescope collect the faintest photons from distant systems, they also turn inward, studying our home planet from afar, calibrating their precision on the familiar before venturing into the unknown. To see Earth from the edge of space is to witness its fragility, a thin blue arc suspended in blackness, a world of oceans and breath, finite yet radiant. That perspective changes everything. It replaces ownership with awe, separation with belonging. The more we understand about planetary systems, the more we recognize their interconnectedness. Dust from dying stars becomes the raw material for new worlds. Meteorites carry elements between planets, seeding chemistry across the void. Even now, fragments from Mars have fallen to Earth, and dust from ancient supernovae rests in our soil. We are not observers of the cosmos, we are participants. Every breath we take contains atoms forged in the hearts of stars that burned billions of years ago. The carbon in our blood may once have drifted through the nebula that formed another planet, circling another sun. The boundary between us and them, between living and lifeless, blurs under the light of time. In the great continuum of creation, life is not an exception, but an expression. Wherever conditions permit, molecules find ways to combine, to copy, to evolve. The chemistry that created us is universal, written in the periodic table, echoed in the spectra of exoplanetary atmospheres. Life, then, may be the universe's way of knowing itself, a pattern repeated on countless worlds, each version unique, yet harmonized by the same physical laws. When we search for other Earths, we are not seeking strangers. We are searching for context, for reflection, for other verses in the same cosmic poem. There is a subtle comfort in realizing that the universe does not waste its patterns. Every experiment in matter contributes to the whole. Some worlds may cradle oceans beneath ice. Others may burn too hot for anything to endure. But each world in its own way refines the universe's understanding of possibility. Through them, physics practices its art, chemistry explores its palette, gravity sculpts its architecture. Creation is not a single masterpiece. It is an endless exhibition, a gallery of attempts and variations, each as essential as the last. Light itself seems to participate in this conversation. It does not merely illuminate, it connects. When photons leave a star, they carry with them not only energy but information. The signature of the star's composition, the rhythm of its pulses, the story of its life. Those same photons may strike a planet's atmosphere, reflect, and continue across space until they reach our telescopes. In that journey, they bind us to the distant world, linking observer and observed through the simplest of interactions, emission and reflection. We are joined by light, entangled in radiance. To reflect upon this is to feel both small and infinite. The galaxies stretch beyond comprehension, yet the same laws that govern their motion govern our hearts. The gravitational curve that shapes a planet's orbit mirrors the curve of a leaf, the spiral of a shell, the structure of a storm. The symmetry of nature is not coincidence. It is kinship. The universe does not exist out there. It extends through us, in us, as us. Perhaps that is the greatest lesson planets teach. They show us that we are not separate observers, but expressions of the same creative principle. Every orbit mirrors the rhythm of our own lives, beginnings, climaxes, returns, restarts. Every storm echoes our moments of turmoil. Every calm sea under alien skies reminds us of our own need for peace. To study the cosmos is to study ourselves rendered in larger scale and slower time. And as we stand here, tiny and transient, surrounded by the echoes of ancient light, we begin to understand that knowledge and reverence are the same thing. Science, at its heart, is not about control, but about appreciation, a way of listening to the universe with precision and patience. The data we gather from distant planets are not merely facts. They are love letters written in radiation, proof that curiosity can cross any distance, that understanding is the most natural act of connection. Now, as our journey nears its quiet close, we carry these reflections like soft lanterns through the dark. The worlds we have visited do not fade. They remain orbiting in our minds, glowing faintly with the memory of discovery. The more we learn of them, the more luminous the universe becomes, not with light alone, but with meaning. And soon as we return to the stillness from which we began, we will find that the echoes of those distant planets linger not in the sky above, but in the pulse of our own awareness, reminding us that we are and have always been part of that song. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. At last, we begin our slow return from the journey away from the distant worlds of fire and diamond, from the twin suns, and the lonely wanderers adrift between the stars. The darkness that once felt infinite now feels intimate, a quiet room rather than an abyss. As we travel back through the folds of light, we carry within us the quiet realization that everything we have seen, the storms, the silence, the rhythm of orbits, and the hum of magnetism, all belong to a single living pattern. We are not separate from it, we are made of it. The same dust that formed those distant planets once drifted through clouds that would become our own world, our air, our bodies, our breath. In the beginning, there was only the hum, the low vibration of energy, dense and formless, expanding into possibility. That hum still moves through everything. It hums in the hydrogen of the stars, in the gravity of galaxies, in the breath we draw each second. We are each a continuation of that first pulse, the universe remembering itself in consciousness. Across billions of years, matter learned to dream, and those dreams became us. The same physical laws that sculpted the planets sculpted the architecture of our minds, synapses firing like tiny stars, thoughts orbiting through memory the way moons dance around their planets. When we look at Earth from space, we see that the line between planet and life is thin, almost indistinguishable. The oceans glimmer with sunlight, like a single living cell suspended in blackness. Clouds drift like breath across the surface, the continents glowing with the subtle warmth of bioluminescent motion. Forests breathing, carbon oceans exhaling oxygen, the whole planet alive in respiration. Earth inhales and exhales over time, scales of days, seasons, epochs. Even the atmosphere breathes, swelling with heat, contracting with cold, balanced between extremes, as delicately as a flame cupped between fingers. We often think of the universe as distant, yet every inhalation we take is an act of cosmic participation. Each breath contains molecules that have passed through stars, through leaves, through the oceans of time. Some of the air you breathe tonight once drifted across the plains of Pangaea, once filled the lungs of a trilobite, once hung above a volcanic sea under a pale young Sunday. In breathing, we are connected not just to one another, but to every age of the Earth, every phase of its evolution. We are quite literally recycling the past into the present. And just as the Earth breathes, so does the cosmos. It expands and cools, forming and dissolving a living cycle written across aeons. Galaxies move apart, stars are born, and one day the expansion will slow, perhaps reverse, perhaps fade into quiet entropy, a long exhalation into stillness. But even that is not an ending. It is simply a change of rhythm, another movement in an eternal composition. To call it death is to misunderstand what the universe has shown us at every scale, that energy never ends. It only transforms, flowing endlessly between light and shadow form, and void, order and chaos. Think of the life of a single star. It begins as dust and gas condensing, igniting, burning through fusion for millions or billions of years. When it dies, it releases everything it created: carbon, oxygen, iron, gold, into the surrounding space. Those elements drift, gather, and become new stars, new planets, new beginnings. Even the atoms that compose us were once part of a supernova's last breath. We are each of us stardust made conscious, the memory of stars looking back upon itself. And just as stars recycle their material, so too does life. The cells of your body are ancient, their elements forged long before you were born. Every beat of your heart is powered by energy that has journeyed across epochs, from cosmic radiation to sunlight to the sugars in your blood. You are the continuation of the same story that began with the first atoms, a pattern so vast that even time itself becomes just one measure of its music. When we see it this way, the universe is not a machine. It is a breathing being, a great continuum of exchange. Energy moves like air through the lungs of creation, inhaling matter into form, exhaling it back into space. The galaxies swirl like eddies. In that breath, stars flicker like cells of a living organism, and we, tiny and temporary, are part of its circulation. To understand this is to find peace in impermanence. The breath does not fear its exhale. It knows it will rise again. This is what planets teach us when we truly listen. They remind us of patience. A mountain does not hurry to form. An orbit does not rush to complete itself. The process of creation moves at the pace of eternity, and yet it never pauses. Every world is in motion, every atom in dialogue. Even the quietest stone vibrates with the music of time. To exist is to move is to participate in the universal rhythm. And in that rhythm, there is tenderness. The same gravity that binds the moon to the earth also keeps oceans within their shores. The same forces that sculpt the rings of Saturn hold together the fragile atoms of our breath. When we look at the stars and feel awe, we are not reacting to something foreign, we are recognizing something familiar. Awe is memory, a recognition of origin. The universe speaks to us in emotion because we are built from its language. It is easy in moments of solitude to feel small beneath the weight of space. Yet smallness is not insignificance. A single grain of sand carries the same geometry as an entire planet. A single heartbeat echoes the rhythm of stellar fusion. Magnitude does not define meaning. Participation does. We belong because we are made of belonging. Every movement, every thought, every gentle breath we take adds to the ongoing conversation between matter and mystery. Perhaps one day, humanity will travel to the worlds we have only seen as faint points of light. We will stand beneath two suns, or on the frozen plains of a rogue planet, or among the rings of gas giants that hum with invisible song. And when we do, we will not have discovered something new. We will have returned to something ancient. For in exploring the cosmos, we are only retracing the path of our own atoms going home by another route. Even now, through telescopes and instruments, and the quiet wonder of human imagination, we are already there. Our curiosity is the universe expanding through us, continuing its exploration in thought and dream. Each discovery, each act of attention, is a kind of breathing the cosmos, inhaling through our eyes, exhaling through our understanding. We are not spectators of the universe's beauty. We are the means by which it perceives itself. So as we drift one final time through this infinite calm, let us rest in the awareness that everything is connected. The stars, the planets, the dust between them, the consciousness within us. The air you breathe tonight is the same air that has circled the earth for billions of years. The light that touches your eyes left its source before your ancestors were born. You are not separate from time nor from space. You are their unfolding, their continuation, their living echo. The story of planets is in the end the story of peace. It is the story of how motion gives rise to stillness, how vastness creates intimacy, how darkness makes light possible. The universe, for all its grandeur, is gentle in its essence, patient, rhythmic, endlessly creative. To know this is to find rest not in ignorance, but in understanding. The stars do not demand worship, they invite calm. The planets do not compete, they coexist. Creation is not war, it is breath. And so we return, as all journeys do, to silence. But it is not the silence of absence, it is the silence of completion. The planets continue their orbits, the stars, they're burning the galaxies, their spiral, and beneath it all the deep, endless pulse of being continues. You too are part of that pulse. You are the still point in its motion, the witness through which it knows itself. Close your eyes now. Feel the rhythm of your breath matching the rhythm of the cosmos, slow, eternal, balanced. With every inhale, you gather the starlight of the past. With every exhale, you release it back into the infinite part of the same endless flow. There is nothing to fear, nothing to chase, nothing to hold. The universe is breathing, and you are its breath.